All right, y'all, welcome back. Let's go into our first example for section 7.1, where we're actually going to be using this idea of critical values and confidence intervals and start to combine these ideas to just be familiar with the vocabulary. So when we're finding the critical values corresponding to confidence intervals, this is very similar to the process that we learned earlier in chapter 6 in one of the previous modules, where we're looking at the inverse normal distribution. And if we remember this idea of inverse normal distribution, we have an area given to us and we're going to be finding that z-score. Okay, so it's going to be very similar to that, but now we have this new idea of like a confidence interval and a confidence level and a critical value. So we're going to be using that terminology instead. Okay, so it's a three-step process when we're trying to find this critical value or this new type of z-score. First, we're going to be looking at the area underneath the curve up to the negative critical value. As we see in this previous diagram, it's symmetric about the mean. So we can use the normal left-sided areas to figure all of this out. Then we'll be looking for the areas using our chart that's given to us for the areas of a standard normal distribution. And we're going to be reporting that corresponding z-score, which again, this is going to be, that z-score will be our critical value. So here we're going to be finding the numbers of z sub 90 such that 90% of the area underneath the curve lies between negative z sub 90 and z sub 90. In other words, we're going to be finding the probability between these two boundaries. Now remember, the first step that we always do for any of these problems is draw it out. So that's exactly what we're going to do. Okay, there's my horizontal axis. Gonna draw out my tails here. Ooh, that little side looks a little rough, but you get the point. Okay, and just for completeness, I'm going to draw that that mean, which we know is 0 because we're working with a standardized curve. And I'm going to shift this up a little bit so that we have more space. And we're looking for a 90% confidence interval between negative z sub 90 and positive z sub 90. So I'm going to label that on our graph here. Negative z sub 90 and positive z sub 90%. Okay. And here we're finding the probability in between these two boundaries. So that would mean that we are finding, we would be finding this area, which, I mean, we don't really have to find it. It was sort of told to us because remember from the previous video, that area is going to be related to our confidence level, which we know is 0.9 or 90%. Okay. So since we know this area that we have highlighted, we need to calculate the area that's in red here specifically. Okay. So to do that, we know that we'll have to find the complement of it because those tails are including everything else that's not within our boundaries. Okay. So to find the complement, we're going to take 1 minus the critical value, and that's going to be equal to our area. So I'm just going to put it as area. 1 minus 0.9, and we're left with 0.1. Now we know that this area is symmetric over two tails. So we're going to have to divide this area by 2. Because when we're looking at the area of the standard normal distribution, that's going to tell us the area to the left of a boundary. And if we're considering the area underneath the curve up to negative z sub c, we're only looking at this part. So that's boxed in green. So this other red area is going to be excluded from our calculation, which is half the area that we just found. So the probability of z being less than negative z sub 0.9 is going to be our whole area that we just found, which is 0.1 divided by 2. We know this value to be 0.05. Okay? So, what we do now is we're going to be looking for the area that corresponds to 0.05 on our chart. Okay, so looking at this chart here, double checking here, we're going to be somewhere within this realm. Now remember when previously we talked about trying to find the closest value possible. Here we actually see two values that are basically the same distance away from it. The 0.0505 and the 0.0495 as our areas. So what I'm going to do is I'm going to take the two potential z values and I'm going to find the midpoint of them. Okay, so that midpoint is going to be taking, for negative z sub 0.9, we're going to be looking at the horizontal and the vertical. So for the 0.0505, we're going to be looking at this row highlighted in green and the column highlighted in green. That intersection is going to be negative 1.64. Okay. Similarly, for the other value of the 0.0495, we're going to highlight the horizontal value and the column. And here we're going to find that that value is negative 1.65. And we're going to divide that value by 2. Okay. So here we see that we have negative 1.64 added to negative 1.65, which is negative 3.29 divided by 2. This number is negative 1.645. And I know this sort of breaks the rule that we talked about earlier about it being like our critical value, only going up to the hundredths. So this would be like our like closest approximation to it, but this would be like the most accurate to it. So we're gonna make an exception here. So we're gonna write it off as this number, and that will be our critical value at a confidence level of 0.9. Okay. And there's the final image of everything that we did. And I will see you in the next video for the next part of this section.